So we are going to start today. We talked a little bit about amplitude yesterday with these first two examples up here at the top, and how the amplitude makes my graph either get like skinnier or a lot wider. So what I wanted to do today is start with something, bless you, that we did yesterday and had some success with, or at least I think we'd had some success with. So we're going to go down to the bottom of this page, and we're going to do a couple more graphs with just amplitude changes. Now, I'm going to try, if I didn't make you a believer yesterday that you didn't need the graphing calculator to do this, I think I can make you a believer today. I'm hoping. Because I'll show you how much longer it's going to take to deal with all the changes you're going to have to make rather than just dealing with your base graph. Speaking of the base graph, this is my sine base graph. We did it back earlier in the packet. And one of the things that I am going to stress is the usefulness of having a basic feel for what that graph looks like. Now, we talked yesterday about how we can figure out these tick marks. How I could say, okay, there's 1, 2, 3, 4 marks, and 2 pi is 360. So if I wanted to know how much each mark was worth, we said all I'd really have to do is take that value and divide by however many lines it built up. But we also talked about the need to talk in Trig's love language, which is radians. So I'm not going to write 90, 180, 270, and 360. I'm going to put them in radian mode. And we talked about the couple of ways you can do them in radian mode. I can either take that particular degree value and divide it by 180 and put it into its simplest fraction form. So for instance, that'd be like pi over 2. We know 180 is pi. And then we could do that same thing for 270. But again, it's always 180 that we're dividing by, because again, it's like converting degrees to radians. You divide by pi over 180. Or we'd also spoken about the way that we could take these and say, okay, well, if this was pi over 2, I would just keep adding another one each time. So it'd be 2 pi over 2, but the 2's canceled, okay. 3 pi over 2, and just add them instead of even needing the calculator at all. You get that first one, oh, 4 divided by 2 is 2. Okay, that's where 2 pi is coming from. And start working it that way. So you have some options available to you. Once I have that set, get this out of the way, what we talked about doing was understanding my base graph and how useful it is when you're graphing these, instead of playing with the calculator for everything and having to reset all this stuff up and make sure it's in radians and make sure your table set's right and making sure of all the stuff that can go wrong. Instead, if I just know, okay, it's pi over 2, pi, 3 pi over 2, 2 pi, it just goes 0, 1, 0, negative 1, 0. It's just a little pattern. Makes a little wave. And then we talked about how that'd be helpful on something like an amplitude change. So like if my a is negative 1/2, we talked about how we need to just multiply the y value by our amplitude. So in other words, I'm going to take that base graph, which is the same every single time, it doesn't change, and I'm going to take these values and I'm going to times it by a negative 1/2, and that's going to tell me, bless you, where the new one's going to be. Cool thing about 0, what's 0 times anything going to be? 0. So any place that there's a 0 when I'm messing with the amplitude, those dots aren't going to move at all. A little harder to see. Let's see if I can make them a little bigger so you can tell I'm getting my red ones here. So for the other ones, I just multiply whatever the y value is by negative 1/2. So 1 times negative 1/2 is negative 1/2. That's where my new dot's going to be. Here, negative 1, my y value, times negative 1/2 is positive 1/2. And then I just connect the dots. Now, if I wanted to do that same thing on the calculator, remember, there's lots of things I'd have to do. I'd have to go to my mode, make sure it's in radians. Because as I was mentioning to the class earlier, I've got another class that's working still in degrees. So you're always going to want to check when you come in here to make sure it's in radians, because it may have been switched the class before. You don't know. So once I did that, then I'd have to plug it in like I did here, negative 0.5 sine of x. But then it's not even as simple as just hitting table and being done. I got to hit second window, go to my table set, and then whatever I want to make these by, I've got to type that in. So, oops, I don't want second. So I'm going to a lot of work here just to make it where I can press table and have it come up. But if I do go to that work, okay, 0 is at 0, pi over 2, which is what we said this 1.57 was yesterday, is at negative 0.5, 0, positive 0.5, 0. So I checked it, okay, I'm right. But understanding what the change is from the base graph to this new one, understanding how to do that without the calculator actually will make it better, because sometimes we plug things into the calculator and we really don't think twice about what we're doing. We just go, oh, the calculator says that, and we do it, and it's like, then we don't get it. So here's what I want you to do on this next one. My amplitude is 5/2. If some of you feel more comfortable dealing with the decimal when you're doing this multiplying, that's fine. It'd be 2.5. And what I'm going to do here momentarily, once we get our axes labeled, and it looks like the same one we had on the first one, so I can get these written in, is I'm going to have you try to make the shifts on this one on your own, and then we'll kind of come back together with it. But again, it all bases from my base graph, in this case of cosine. Those 5 dots are going to be what I'm moving around to get my new graph. So kind of take that first example we did into consideration, and now take a moment and shift the points you need to over here and connect them, and I'll uncover this again in a minute, and we'll see if we're on the same page here as far as using our try it out, try it out, try it out. Because you should get something that I would say looks significantly different from the base graph in this case. I see a couple of you still connecting here. I'll wait a little bit longer and then we'll get this on here for you. Okay. So yeah, heading the same direction. We just got a little more of a dip because those ones went up a little higher and that negative went down a little lower.
Wait, how did you get it to go higher on, like, going up? Because, like, it's 2.5, right?
Yes.
Okay, yeah, how did you get that?
Because since these are at 1, if I do 1 times 2.5, I get 2.5.
Okay.
So since both of those are 1s, that'll boost both of those up. And then it also boosts my negative down more into the negative. But again, that's how the amplitude's going to work. So that number that's in front is, again, it can do lots of things. It can kind of make things skinnier. It can flip them. It can make them dip more. Lots of things. But, and I want to do one of these with you, just to let you see that you'd be capable. I'm not going to do this to you on a worksheet. I might do this as extra credit in the next quiz. If we flip to the back of that page, what we're looking at here is they give me this new sine function, but they want me to come up with the expression or the equation for it. So here's where I say understanding the base graph comes in handy. Now let's check a couple things out here. Looks like we're still going to 2 pi with 4 lines here. So we know this isn't going to be different. So we're comfortable there. Looking at your y-axis though, are we going by 1s like we did in the last couple? No. What are we counting by now? 2s. That's important because when we start shifting things, we want to shift them the right way. And if we don't even know we're counting by 2s, that could be a little tricky. You're like, okay, but still, how am I supposed to figure out these different parts? Well, what I want you to do is start kind of working on getting this remembrance of what the base sine function looks like. Now, if you need to flip back for now, that's okay. But the sine function is always going to start at 0, and then it goes up to 1, down to 0, down to -1, and back up to 0. It just makes a wave. You're like, why'd you draw the wave though? It didn't tell us to draw anything else, just told us to write the sine function. But by knowing my base graph, now I can make comparisons. So just like before, whatever was at 0 on the base still was at 0 on the new one. It's these other ones that are going to give me all the cool information. For instance, at pi over 2, the base graph's at 1. The new graph's up at 6. What's my amplitude? 6. Because, remember, whatever we have this by and multiply it by, it goes up here. So if my amplitude was 6, 1 times 6 would be 6. -1 times 6 would be -6. And I can figure out the expression just that quick. But again, it takes understanding my base graph to do that. And that's why the base sine and cosine graphs are so important. Okay? I just wanted to give you a little preview of one of those. I don't want you going crazy with that stuff. All right. So we are going to flip over here to example 7, well, at least the example 7 page. And we're going to start talking about this D parameter. Now, this D parameter is going to be our up and down shifts. Okay. Just like before when we graphed parabolas, square root functions, logs, all of those we had an up or a down shift if the value was outside the parentheses hanging out at the end. So again, you'll notice on these, the base graph is provided to give us something to work with. We're still not having to mess with these yet. I always want to have all my little tick marks labeled so I know what I'm getting myself into. And it looks like we're back to dealing with by ones here. Labeling, always a good idea. So they give us our initial 5 points we're going to work with. And this is why I say this is easier, because once you've made the sine graph a bunch of times, it just becomes second. You're like, okay, quick sketch this. And I start looking, and I see I've got sine of theta, my base graph, -2. What's the -2 mean? Which direction are we going to be going? Down. Now this time, it's going to affect every point. Every one of those 5 base points I made, I'm just going to go down 2. Okay. The wave itself doesn't change. I just made a nice little symmetric wave out of this. Can I punch this in on the calculator? I sure could. But again, by the time I just do a quick sketch, move them all down to, some of you will still be typing this in. If I did want to do it on the calculator, here's the one thing I got to watch out for. I've got to make sure I close the parenthesis on the x before I do the -2. Because otherwise the calculator is going to think I'm shifting left, right, and that's not what I want to do. And you notice now it's down here, and if I look at my chart, 0 is at -2, pi over 2 is at -1, pi is at -2, -3. So again, either way works. I still think just sketching the base graph quick and then moving them is faster, but that's just me. B cosine, same idea. Still no change there, okay. We'll mix that up a little bit here in a bit, make it a little more exciting. And again, it's those 5 base points that create the graph that we want to play with. Which way are we shifting this time? Up 4, because it's plus 4. Every one of those points goes up 4 from where it was. Again, symmetrical to the original, just moving up or down. And that's how the D parameter is going to work. So now we get to see how good of experts we are. Because you might notice if you've taken a peek down at C and D, we get to mess with both the amplitude and our vertical shift, our up or down shift. So this is where we'll have a good chance to see if we've got this or if we still got to mess with a few things. All right. We get stuff drawn in here. They were nice and gave us the original sine graph. And again, I'm looking at those 5 dots. Kind of give myself an idea what's up here. She's like, okay, how's this work when I got 2 different things that are working this time? How am I going to mess with this? We're always going to do the amplitude first. So remember, when we're doing the amplitude, we're multiplying the y value by, so we're multiplying the y value, in this case, by -1/2. That's my first job. But I'm not going to put the dot yet, because my d value of 2 means we're going to shift it up 2. So there's 2 pieces on every one of these dots. So multiply the amplitude first, shift second. So I look at this one, I go, okay, I'm at 0. Multiply by -1/2, I'm still at 0. But then I shift up 2. If you have any other dots that have the same property that start at 0, they're going to end up in the same place. So since pi also starts at 0, it'll end up here. Since 2 pi starts at 0, it'll end up here. So I can save myself a little bit of time and effort that way. But these other ones I still got to do. So my y value here at pi over 2 is 1. 1 times -1/2 would put me at -1/2, but I'm not putting my dot yet. And then I go up 2. So I'm starting at -1/2, and I go up 1, 2. You're like, ooh, I can end up in the middle? Oh, yeah. And then my one other dot. -1 times -1/2 is +1/2. And then I go up 1, 2.
Wait, you said -1/2 times 1 is?
-1/2.
Yeah.
But on this one, I'm starting at -1. So yeah, so -1 times -1/2, negative times negative will put me at positive. And then I'm shifting up 2 from there. Oh, this one?
Yeah.
Okay, so 1 times -1/2 would be -1/2.
Yeah.
And then from there, I'm going to go up 1, 2.
Oh, you're just doing the, oh, okay. I thought you were just doing the amplitude, not the shift.
Gotcha, yep, doing both of them. And so you can see the negative amplitude kind of flipped my graph over, but then the shift moved it up. So I get to see all sorts of strange symmetry with this, but that's how these are going to work. And then it's the same thing with this last one on D. I'm going to multiply by 1/2 first, because that's my amplitude. But then a negative D value means I'm going to go down that many. And especially when it gets fractional, you've really got to take your time and think about it. And again, this is where I'm going to push some of you away from the calculator, because I honestly will continue to say and feel that just having a basic feel for the base graphs is going to make this a lot easier than possibly making a button press error on a calculator and not knowing that you even did. So, okay, I look at this first one, And I notice right away, these two are the same. So whatever I get for this one, I'm going to do the same thing here. So I multiply the 1 by 1/2, which would put me at 1/2. But then I go down another half, which puts me at 0. So I'll be at 0 for both of those. When I'm here, okay, 0 times 1/2 is still 0, so I'm still here. And then I go down 1/2. Down 1/2. Sorry, my dots are in the middle of my descriptors here. And then this is the weirdest one of all. I'm at -1 to start. Times 1/2 would get me to -1/2. But then down 1/2 puts me right back where I started. That can happen occasionally. So basically, the only thing that happens here, it shifts down a little and it also squishes in a little bit more because of the half. But the nice thing about this is I get to see the base and the change, which also would awaken me if something looks kind of weird, which a calculator's not going to do. Questions before we get into our newbie thing of the day, the period. No, not yet. Okay. We are going to go past example 8 because, again, I want to work on the ones that are actually ready for us here more than the ones that aren't. So we're going to jump up here into the world of period, the B parameter. All right, when we're dealing with a period, we talked before how it goes with our sine and cosine functions over a 2 pi or a 360-degree period. However, we've never had a number in front of our theta that changes the period. And here's how this works. If there's a number in front of my theta, notice amplitude's going to be out in front. This one will kind of split your trig function in that theta angle. So that 2 that's there is actually going to squish our graph down some. So stick with me here. Here's how this is going to work. I notice a couple of things about this graph they've given me. Now, they gave me the base graph. That doesn't look normal. It looks bigger than it normally does. Oh, wait a minute. They stretched this out. 1, 2, 3, 4. And it goes up to pi, which is 180. So this is going to be a little bit different the way this one sets up. So to get, so that 180, that pi is divided into 4 pieces. Okay, so each of them are going to be 45 degrees. So I may have to think about this for a minute. So if they're each 45 degrees, let's just keep adding some 45s here. So 45 degrees, I got to remember what that fraction is. Okay, once I get this first one, I should be good. 1 over 4. Okay, so this is pi over 4. So remember, I can keep doing the calculator. I could do 90 over 180, 135 over 180, or I can remind myself I can just keep adding a pi over 4 to each of these, and then just simplify the fraction that's there. And I'm probably not even going to need a calculator for any of them. So if I just think about it that way, 2 over 4 is a half. 3 over 4 doesn't reduce. 4 over 4 cancels. Okay, that's pi. And again, I think your brain, more times than not, is going to be faster than the calculator is. Because fairly quickly, I can get that all lined up. So I look at that and I go, okay, are my points still in the same spots? Yep. Still at 1, 0, -1, 0, 1. They're just a little more spread out because we've broken up our angles into a little smaller of a grouping, but that's okay. So I look at this and I say, all right, so I have a b value this time. My period value is going to be 2. So 2 pi divided by 2 is pi. You're like, okay, what's that mean? What that means now is this graph that we originally drew in the base that takes up 2 pi of space, we're going to squish it where it only takes up pi amount of space. Like, well, how you do that? That's kind of weird. Well, it's actually not that tough at all. So here's what we're going to do. We know right now that our values are at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And the cool thing is that never changes. That's where my base values are going to be for cosine and sine. I want to divide those angle measures by 2. Well, if you divide by 2, that's the same thing as multiplying by a half. So I'm going to multiply every one of these by a half, and that's going to give me the new place that that particular value is going to be. So stick with me for a second here. I just want to show you where they come from first. Because our b value is 2, so we're going to divide our whole period by 2. So when we divide by 2, it's the same as multiplying by a half. And so what I'm doing right now, and you notice I end at pi, which is where this is going to be. So here's how this works. At 0, okay, we're still at 0. So this guy doesn't move. He's going to get to stay there. Pi over 2 is normally right here at 0, but it's moving. It's going to move to pi over 4. So notice the y value didn't change, it's just moving over. We're going to start squishing things. My pi, which was right here, now is going to move over to where pi over 2 is. We're cutting all of these original values that we use in our base graph in half. 3 pi over 2, okay, which was at 0, now it's going to go to 3 pi over 4. And my 2 pi, which was up at 1, is now going to shift over. So what you've done is basically you've taken a very wide graph and squished it into something very small. Now, if you need to, and some of you may, I totally get it if you do, if you want to look at it this way, you could. I had somebody show me this earlier, and I'm like, okay, this is sensible to me. You may want, instead of drawing it this way, where you don't get to see the values, somebody asked me earlier, well, could I make a chart out of it? And I said, okay, what do you mean? And they're like, well, if I take the original values that I had, that I started with, I said, okay. Well, then I'll go ahead, I'll cut them all in half. I'm like, okay, so you cut them in half, you multiplied by 1/2, okay. I'm like, this looks like mine so far, but I'll work with you. They said, but then I want to actually see where the values are going to be. So like before with 0, the value was at 1. And then I was at pi over 2, the value was at 0. And then it was at -1. And then it was at 0, and then it was at 1. And I just want to cross out the original ones, because now I know, okay, 0 is at 1. Pi over 4 is at 0. Pi over 2 is at -1. 3 pi over 4 is back at 0, and this is back at 1. Can I do that? I'm like, sure. And it's sensible because you get to use the shift, but you also get to see directly where every single point goes. Because some of you have been saying, well, can I put this in the calculator? Yes, but you're going to have to know where these new shifts are. And let me explain. If I tried to put this in the calculator, which I can do cosine of 2x, okay? Graph it. It's going to squish a little more. But when I go to do this, you're like, well, wait a minute. Everything's 1 and -1. Where are the zeros at? These are all still based on when we were using pi over 2. You'd have to go back in and change your table set to dividing this by 2, which would be pi divided by 4. And that's the part that people usually start getting themselves in trouble with. Okay, there's my 0, 1. There's my pi over 4, 0. There's my pi over 2, negative 1. It works, but do you really want to have that many things that can kind of nab you? The cool thing is with this, I don't even have to keep making a chart to make the rest of this, because I'm noticed 1, 0, negative 1, 0, 1. It just starts coming back down. 0, negative 1, 0, 1. And I can make the graph over the entire bit, and I get this big old W shape. I get 2 whole cycles in one. But the trick is, and we're going to see it again here in letter B, if some of you are still a little foggy going, yeah, I'm not absolutely sure about this. But here's how it'll work. Okay, again, now, ooh, they set different. How many lines do I have this time? 1, 2, I always got to count the one here too. So I've got 3. So 180 divided by 3 is going to give me a 60-degree angle. So I got to get that 1 situated, and then I should be all right. So 180 divided by 3 is 60. So let's see what we get. Okay, 1/3. So I'd have pi over 3. And then I'd have 2 pi over 3. Because remember, we just keep adding 1. 3 pi over 3 is just pi, so that works. 4 pi over 3. 5 pi over 3, and then 6 pi over 3. 6 over 3 is 2 pi. So I have to be able to adjust to that. And you're like, well, then what's this original graph they're giving us here? Because this looks kind of strange. Well, what they've done is you've still got 0, 0. This is still pi over 2, even though it's not labeled there. Again, like I said before, your base graphs are never going to change. Pi is still at 0. This is still 3 pi over 2, just like it always has been. And this is still going to be 2 pi. And we're going to do the same thing that we did on the last one. My period value is 3. So my period's going to be 2 pi over 3. So you're like, you're going to get that whole graph in this little area. Yes, I absolutely am. And here's how. We're going to look at it like we did that last one and kind of chart this. So again, I have to have a grip, though, on my original 0, pi over 2, pi, 3 pi over 2, 2 pi. Again, never changes. But this time I'm dividing them all by 3, which means I'm going to multiply by 1/3. I'm going to multiply by 1 over whatever this b number is. So when I do that, we'll get our new values here in just a second. So that'll still be 0. This will be pi over 6. We'll discuss how we're going to deal with that in a minute. Pi over 3. Let's see, this would be 3 pi over 6, which reduces. And this would be 2 pi over 3. Notice it ends the same place that we thought it would when we actually divided it. So you're like, okay. And then remember, these guys, when we're doing sine, it's 0, 1, 0, negative 1, and 0, just like we saw in our original points. So this becomes where I'm graphing. I graph at 0, 0. You're like, what's this pi over 6 thing? Okay, let's think about it. I know I'm making some of you think a lot. Some of you, I know, aren't big fans of thinking a lot, but that's okay. Since pi is 180, that's 0. This is 60. We'll put a label in between. So pi over 6 puts us up here at 1. Pi over 3, which we have, puts us back to 0. Pi over 2, which we have, bless you, puts us at -1. And 2 pi over 3 puts us back to 0. And just like that, you have one complete cycle, just a very smushed version of what you have over here.
Can you explain how you did the 1/3 again?
Sure. What I'm doing whenever I do anything, and I'll put a different example up here. I'll even use this one again. Whenever I see what this b value is, whatever this number is in front of theta, what I have to do, according to my little formula here, is I'm going to take my 2 pi, and I'm going to divide it by whatever that b value is. So normally, my graph, if I look at it, goes all the way across to 2 pi. But now I'm cutting that into 1/3. It's only going to be 1/3 as big. So if I'm dividing by 3 here, which is what I'm doing, dividing by 3 and multiplying by 1/3 is doing the same thing. So when I am, where'd my little sheet go?
Oh, okay.
So all I'm doing then is I'm taking those original 5, 0, pi over 2, pi, and so on, and
Like
multiply.
where the points are is where you, okay.
Yep. So I'm still going to be at the same 0, 1, 0, -1, 0. It's just now at what point am I going to be putting those? Nope, because, well, you could. It'll be one of those things like we talked before, because the question was, in case it won't be able to hear this later, could I do this in degree mode? It's one of those, like we said before, when some of you were making conversions and you liked going from radians, put it into degree, but then I said you'd have to put it back into radians later. If you wanted to go through all of that, you can. If you really want to go to all that work, I don't think I'd want to go through all that, though, for this. That's why I'm just going to kind of keep pushing the fact that you really are going to want to deal with base graph. Keep the note sheet available with you as you're doing this. That's not a big deal. Keep that with, get the base, and then try to play with it that way. So here's what you're capable of. Well, I can say it before I hit record on this. Like I was saying earlier, you're now capable of getting through all of the first packet that we got yesterday. And you're good on 1 through 8 in the new one. The rest of them in that new one we're going to talk about tomorrow, because we haven't talked about left and right shifting yet. We're going to do that, and then I'm going to give you the rest of the time tomorrow to work on these. But again, you don't need a calculator. Have the base, try working on them. I know how some of you are. If you wait until tomorrow and have done none of them and just are throwing your hands up, this next quiz is going to be very painful, and I'm not going to have a lot of remorse.